Hi, let's continue our discussion on ratios, rates, and conversions. And still, our goal will be to find ratios and rates and convert units and rates. So for this next problem, we have what we call as the dimensional analysis. So dimensional analysis is when the units for each quantity are included in the calculations so that it could help determine the units for the answers, okay? So let's have this example here. So the CN Tower in Toronto, Canada is about 1815 feet tall. About how many meters tall is the tower? So as you can see, the given unit of measurement is in feet, and the question is asking us to change it to meters. Now, the fact that 1 meter is approximately around 3.28 feet, that information is what we will use to do our computation. And so we can apply what we have just learned about changing rates and things like that. So since we are given 15 feet, okay, our conversion factor, we can set it up. So again, you will always have the given unit in the denominator. So in this case, oops, sorry, pardon my supposedly straight line. Okay, so the given unit is in feet and our desired unit is in meters. So according to the fact that 1 meter, so just put 1 with meter and 3.28 in the denominator. So again, we can cancel feet divided by feet, that's equal to 1, okay? And so this will give us 1815 meters divided by 3.28. And so if you do the computation for this, it will end up to be 553.35 meters. Okay, so just be flexible as to what Math Excel would like. If it wants you to round to one decimal place or to the whole number, just follow what it requires, okay? All right, let's have another example. So same thing here. The building is now 1450 feet tall. How many meters tall is the building? And we are still going to be using the same conversion. 1 meter is to 3.28 feet. So go ahead, try this one out on your own. So if you use the example that we just did previously, it uses the same conversion. And so 1,450 feet eventually will be around 442.7 meters. Okay. This next example, if you will see, is going to be using money. Okay, so this is the exchange rate for dollars to euros. $1 is equivalent to 0.63 euros. About how many euros could you get for $325 on that day? So we are given the unit in dollars. So we have $325, and when we have our conversion factor, dollars will be in the denominator. So according to the conversion, oops, sorry. My handwriting is just failing me today. I'm sorry. Let's get that back here. So dollars will be at the denominator, so that's $1, and euros is 0.63. If I remember it correctly, like it's something like this. That's the unit for euro. Okay, so 0.63. Okay, so dollar unit is gone. Dollar divided by dollar is 1. Luckily for us, we will have to multiply 325 and 0.63 divided by 1. So we don't care about that denominator anymore. And when you multiply 325 and 0.63, that is going to be around $204. And I'm sorry, 204 euros, 204 and 75 cents. There we go, 204.75 euros for the $325 that you have. Okay, so this time we will be working on converting rates. Now remember, rates are units of measurement, but they are representing two different quantities, like meters per second. Meters is distance, second is in time. Okay, so how do we convert rates? So if you're going to take a look at this problem, we have a student ran the 50-yard dash in 5.8 seconds. Now the question is, what is that speed if the unit of measurement being used is miles per hour? So for our answer here, we have to round it to the nearest tenth, so 1 decimal place for us, okay? So first thing, start with what we are given, okay? We are given 50 yards in 5.8 seconds. So per 5.8 seconds. So yards is in the numerator, 5.8 seconds is going to be in the denominator, okay? So first thing, let's convert yard, okay? We need to change yard to become miles, all right? And so in this case, I'll use the blue ink here. We will convert yard to our other unit, which is in miles. And so how many miles, how many yards in 1 mile? If you Google, or if you're somebody who remembers all those numbers quite easily, 1 mile is equivalent to 1,760 yards, okay? So why do we have to do this? So that we can get rid of the given yard, okay? Yard divided by yard is 1. So what is the existing unit of measurement for distance? Miles is the only one left in here. Now, how do we change second? Okay, so we will have a second conversion factor here, and this one is in green, and this is reserved for converting second. Okay, now as you can see, seconds in our given is in the denominator. So do we need to put it also in the denominator on our conversion factor? Nope. Okay, always remember, when you have rates, you will have to use the location of the opposite on your conversion factor. So seconds is given in the denominator, which means in the conversion factor, seconds will be in the numerator. And what is our desired unit of time? It has to be in hours. Okay. Now, if you would convert how many seconds in an hour, we know that 1 hour has 60 minutes, 1 minute has 60 seconds, so there are 60 times 60 seconds in an hour, so that would be 3,600 seconds for every hour, okay? So what do we do here? You have seconds in the numerator, divided by second in this denominator here. So the unit second is gone, and the only unit of measurement for time is hour. So what do we do here? Okay, so now that we have our desired units ready to go, what we simply do is multiply everything in the numerator, multiply everything in the denominator. Okay, so in our numerator, we have 50 times 1 times 3,600. If you do your calculations, it will be equivalent to 180,000, and the only unit of measurement left in a numerator is miles. Our denominator, on the other hand, 5.8 times 1760 times 1, that will be equivalent to 10,208, and the only unit of measurement, as you can see, is hour. Okay, and then since we are looking for an answer to the nearest tenth, you do the division of these two, so we can say that the speed 50 yards in 5.8 seconds is equivalent to 17.6 miles per hour. Okay, so we were given yards per second. This time it now is in miles per hour. Okay, so you can try this next example on your own and find out what is the speed of this athlete in miles per hour. Go ahead. So for an athlete who can run 100 feet in 3.1 seconds, that means that athlete's speed is 22 miles per hour. Okay, so to summarize, You can write ratios and find unit rates to compare quantities. And you can also convert units and rates so that we can solve the problems. Thank you.